Okay, so here we go again. As you can see, this was the last medium-sized heating element, which I benchmarked. That was a little surprising. It didn't quite get as high as I was hoping. And so we've iterated a bit, and now we have a heating brick. So this is double the silicon carbide amount. It's also a good bit thicker. Hopefully that'll retain some heat a little bit. So we're going to go ahead and put this in a crucible, and we're going to do the same 30-minute trial and see where we land with the brick. Also, side note, I've been meaning to do this for a long time now, but finally got around to mounting the ventilation up here and rigged it up a little bit on the cheap, but it'll do. See ya, Space Cowboy. Okay, so after 30 minutes, we are actually seeing a very similar result to the medium-sized heating element. Now, I feel like I should clarify, this is very hot, I'm not going to touch it. But the brick, when I said had double the amount of silicon carbide, I meant double in the same location. So two heating elements that were printed were stacked together, whereas in the medium size, we actually have a silicon carbide isolated by a layer of refractory, and over here is another silicon carbide element. So they're separated, whereas in the brick, if you can imagine this, two of the same elements are stacked together, almost in series there, and a little bit more layer of ballast was, refractory was poured around. So the hope was that this would concentrate the heat a little bit better, but it doesn't seem to be doing that. And actually, I'm getting the exact same results as the medium. I have half a mind to test this a little bit further just to see if it can carry it a little bit more. So I think what I'm going to do is do about 20 more minutes on this and just measure it out and report to you as I see it. So here we go. Alright, so I'm ramping down. This is at 70 minutes, which is a little bit longer than what I was anticipating. But the interesting thing, as you can see we're cooling down here, the interesting thing, I've already measured this, and we have actually increased the ramp rate at which we can achieve after the 70 minutes. So this lines up with some of the earlier tests where at some point, when we reach some critical temperature, we actually increase the rate at which we can heat. Not high. We're probably peaking right now at around 910, but the estimated was about 850 degrees Fahrenheit. So we've surpassed what we thought we could, and the rate has increased. So I think what we're going to do is try to see if we can max this out with the medium medium element over here. We did reach a maximum temperature of around 910, and for now, it seems like we're just getting started. Hello. What are you doing here? Just keep walking. Goodbye. Anyway, so what we're going to do is zap this for another 20 minutes, I think, and see if we hit some critical limit. Okay, sad day. Well, we did what we could, but after 90 minutes in the 1100 watt microwave, we did max out. The final resting temperature of the internals was around 878 degrees Fahrenheit. This was decreased from the peak of 910, which we achieved at around the 70-minute mark. So, unfortunately, I think we still have a few more tests to do, but I think it still just involves adding more silicon carbide to our heating elements, and we are just waiting on a little bit of filament for that to continue. So anyway, thanks for tuning in, and cheers. Catch you in the next one.